Hello, this is Mr. Win, and this video is about multiplying rationals. So, rationals are just fractions. Remember, when multiplying fractions, the top multiplies the top while the bottom multiplies the bottom, and there's usually reducing involved as well. So there are two main ways to multiply fractions. A lot of y'all use the old way, where you multiply and then reduce. So, for example, 6 over 25 times 10 over 4, you multiply the tops. 6 times 10 is 60. The bottom times bottom, 25 times 4 is 100. They need to reduce this. I know that both of them are divisible by 10, so I divide top and bottom by 10. I get 6 over 10, but that's still reducible. They're both even, so I could take out a 2. I divide top and bottom by 2. I get 3 over 5. So that method works fine if everything's a number, but it's not going to work too well in this unit because we now have more than numbers. We're going to have letters. We're going to have polynomials, variables. So you need to learn the new way. The new way is also more efficient, and there's smaller numbers involved. You're not going to see, for example, 60 over 100. The new way is like reversing it. So instead of multiplying and then reducing, we're going to reduce first, multiply second. But to figure out what to reduce by, you have to factor. So my first step would be factor everything, every numerator, every denominator. So the 6 turns into 2 times 3, and then 25 turns to 5 times 5. Then since it's multiplication, it's just going to be one fraction anyways. I combine it to a single fraction. 10 turns into 2 times 5, and then 4 turns to 2 and 2. So now I fully factored everything. Next, hopefully you remember, if it's something on top and bottom, they cancel out. So you cross things out one at a time in pairs. So for this first 2, cross out 1 and 2's on bottom, then this other 2, cross out the other 2, then this 5, cross out that 5. What's left over is your answer. If there's single things, they multiply, but it's just a single 3 on top and a single 5 on bottom. Now if you notice, I divided by 10 up here. This 10 came from a 2 times a 5. Then what's left over was this last 2. That's where this 2 came from. So it's the same idea, it's just showing the work differently. We're basically keeping the number small, not needing a calculator, being more efficient. So now that you understand the reasoning for the new method, let's officially write the steps, as there is one tricky part. So step 1, factor everything, every numerator, every denominator. Remember, you do GCF first. Then if it's 2 terms, you do difference of squares. If it's 3 terms, you can do guess and check, trial and error, X method, grouping, whatever your teacher showed you. Then you can find restrictions. Numbers on restrictions, but then there's letters. Remember, you can never ever divide by 0. So to set every factor in the denominator equal to 0, and then solve for the not allowed answers or restrictions. And lastly, the fun step is if it's on top and bottom, cancel out. Remember, one thing crosses out one thing. So if there's a 1, 2 on top, but 5 2's on bottom, you cannot cross all the 2's out. It's 1 for 1. So here's the problem. 2x plus 6 over x squared minus 25 times x plus 5 over 6x plus 18. So first one factor, 2x plus 6. I see this is GCF. I can pull out a 2. What's left over would be x plus 3. I can't do into that. Then on top, that x plus 5 has no GCF. It's linear. It stays the same. And I put it in parentheses because that means it's being multiplied. On the bottom, x squared minus 25, that is a difference of squares. So I do x, 5, 5, plus minus. Then for 6x plus 18, there's a GCF of 6. But 6 is not, 6 you can break down. So I change 6 into 2 times 3. Then if I took out 6, what's left would be x plus 3. So that is fully factored. Step 2 is find the restrictions. Remember, the bottom cannot be 0. Remember, this is multiplication. So if this first factor is 0, it doesn't matter what these are, because 0 times anything is still 0. So I'm going to go in order, look for the bottom. The first factor I see the letters is x plus 5. It cannot equal 0, so I solve this. I subtract 5 both sides. I get x cannot be negative 5. Here's another x, so I have to solve that as well. So x minus 5 cannot equal 0. Right? Add 5 both sides, I get x cannot equal positive 5. 2 is a number, no variable, so I skip that. 3 is just a single number, no variable, I skip that. X plus 3 is a letter, so I have to solve that as well. X plus 3 cannot equal 0. I solve that, get x cannot equal negative 3. We found our restrictions. Now we're going to cross out. So I just recopied it. This 2 crosses out this 2. X plus 3 crosses out x plus 3. X minus plus 5 crosses out x plus 5. Now the top is empty. You must put a 1 there. If the bottom is empty, you can just skip it. Or you put divide by 1, but that doesn't do anything. The bottom has 2 things, so we just leave them alone. You do not have to multiply it out or FOIL or anything. The only things I have to multiply are single things. So if there's like a 3 and a 6 somewhere else, I'd multiply to get 18. Once you have your final answer, for good habit, write your restrictions, where x cannot equal negative 5, negative 3, and positive 5, where I got these right here. So this right here is my final answer. Let's try one more. Here's the problem, that times that. Step 1, factor everything. This top has no GCF, but you can factor that trinomial. I do guess and check, so x, 3, 2, then it was plus plus. 12x squared. 12 you can break down to 2 times 6, but 6 not prime. 6 is 2 times 3, so that's why you see me writing 2 times 2 times 3. That's 12. Then x squared is x times x. On the bottom, 4x. Well, 4 is just 2 times 2, and then x is just x. This trinomial, I do guess and check, so 3x, 1, 2. I checked it. It makes 7 plus plus, and I checked the signs. So that's fully factored. Find the restrictions from the bottom. So I skip this 2 because it's just a number. Skip this 2. This is a letter x. I must use that. So I'll set that cannot equal 0. Well, it's already solved, so x can't be 0. This next one, 3x plus 1, can equal 0. So you have to subtract 1 first and then divide 3, meaning x cannot be negative 1 over 3. And then x plus 2, so that equals 0. Solve, subtract 2 both sides, get x can equal negative 2. Found my restrictions, now I do the crossing out step. So you see x plus 2 crosses out x plus 2. This 2 crosses out 1, 2. This other 2 crosses out another 2. There's no 3's crosses out x, crosses out x. A lot of people miss that. And that's it. So on top we have two things. It's x plus 3 and x. You should put the single thing first. Oh, and the 3. So I multiply the single things, 3 and x, multiply to get 3x, and then leave this x plus 3 in parentheses. On the bottom is just 3x plus 1. There's something else to multiply, so it does not need parentheses. Then you write your restrictions. So make sure you follow steps in order. So step 1 is factor, step 2 is restrict, step 3 is cancel. If you cancel before you do restrictions, you will miss restrictions. Because some people think there's only one restriction here, but they forgot there was the original x and this x plus 2. Alright, that's it for the video. Make sure you ask any questions. See you soon. Take care. Bye.